Chapter 2.6 Algebra of Functions. Okay, first let's learn the definition of operations of functions. Okay, let's say there are two functions, f of x and g of x. Okay, when we add these two functions, we can write something like this. Okay, put parentheses and f plus g. Okay, f and g is the name of the function, and then of x. Okay, this means this is exactly the same as adding two functions, f of x and g of x. Okay, it's really simple, but we gotta be careful with the notation. F plus g parentheses x. This means what? Adding two functions, f and g, which is f of x plus f of g of x. Then how about the domain? This is important part. The domain part is this one. Domain is always the intersection of two functions. So it's gotta be, let's say, domain of f, let's say the domain of f, and the intersection, domain of g. Okay, so, the function is all different. So if a function has a, domain, if both of them are all real numbers, then it's okay. The intersection of all real numbers of two functions, is same as all real numbers. But if one of the function has a domain, not all real numbers, then it has to be the intersection. Okay, always intersection of two domains will be the domain of the sum of these functions. So this one indicates the sum, addition. How about subtraction? Then what we do is just subtract the difference. So f minus g of x. This means make a difference, find the difference between f of x and g of x. So f of x minus g of x. That's the subtraction. Oh, well, let me write it as difference is better, isn't it? Difference. Alright, so also the domain will be the intersection, intersection of domain of function f and the function g. Okay, how about the product? The product is a multiplication, right? Multiplication of two functions. It's also simple. Use the product symbol, dot, f dot g of x. This means product, but this is not a circle. Circle is a composite function, so this is just a multiplication, dot. So f of x times g of x. Also, the domain is the intersection of two domains. Okay, the last one is the quotient. The quotient is a division, right? Division. So, parenthesis, f over g of x. So this means we are dividing the function f of x by g of x. And since this is a fraction, okay, the domain is always the intersection, but here's another condition. Since we know that the denominator cannot be equal to 0, right? Denominator cannot be equal to 0. So in this case, g of x should not be 0. That means, all the x values that makes the denominator is not included. All right. Okay, then let's try example finding the domain. Okay, example 1. Okay, let's say f of x is equal to square root of x minus 1. Now in this case, the domain of f, what's the domain of f? That is, the inside the square root cannot be negative, right? So inside the square root, the radical has to be always greater than or equal to 0. That's the domain. So we can set, so from here, x minus 1 should be greater than or equal to 0. That means x is greater than or equal to 1, right? So this is the domain of function f. Okay, how about g of x? Okay, the g of x is x squared minus 4. Then what's the domain of this function? The polynomial is always all real numbers. All real numbers. real numbers. Okay. In a polynomial, x can be any real number. So when we apply the sum, okay, f plus g, then we want to find the domain, right? Domain. Then the domain will be what? Look at this. The intersection means the overlapped area. So f of x is, here's a 0, here's a 1. F of x is always greater than or equal to 0. So I will include this 0. And then greater than or equal to 1, right? So all this part, all the right side of this 1 is the solution. And for the g of x is all real numbers. G of x is all real numbers, everything. It contains everything, right? So the overlap area is what? Only this part. Right? So the domain will be what? X is greater than or equal to 1. All right. Even, f minus g is also same. F minus g is still same. This one, and then f times g of x, all these three has the same domain. X is greater than or equal to 1. But how about the division? F divided by g of x. What's the domain for this one? The intersection, which is x is greater than or equal to 1, and there's another one. The denominator cannot be equal to 0, right? And the denominator cannot be equal to 0. So g of x, and g of x cannot be equal to 0. So g of x is x squared minus 4. This one cannot be equal to 0. So let's make it 0 and then find the x. Then this is x plus 2. Well, let's try this. X squared equals 4. So x equals plus or minus 2. Right? So actually the domain is x has to be greater than or equal to 1, and then x cannot be negative 1. Negative, positive, and negative 2. So look at this. Let me graph it. So from here, x has to be greater than or equal to 1, all this area, and then x cannot be equal to 2, right? So cannot be equal to 2, not this one, and negative 2. So it's got to be everything except 2, everything except 2. Everything except 2. So the domain is, so from here, domain is what? X has to be greater than or equal to 1, and from all these x values, that is greater than or equal to 1, and x cannot be equal to 2. All right? Not equal to, not equal to. Can you see it? All right. So it's got to be, the domain is always the intersection of two functions. So from that domain in the overlap area, if there's another restrictions, then remove it from the solution, from the domain. All right, then next example. Okay, there are two functions, f of x and g of x. We want to find f plus g of 5. Okay, this means we're going to add two functions, right? Two functions. And then we're going to replace this x with the input value 5. So this means we are adding two functions. So f of x plus g of x. And then replace x with what? 5. All right, then x squared minus 9 plus 2x plus 6. So that equals x squared plus 2x minus 9, right? So from this one, let's find f plus g of 5. So we're going to replace x with 5. So 5 squared plus 2 times 5 minus 9, then 25 plus 10 minus 9 equals 26. Is that, sorry. Okay, negative 9 plus 6 is negative 3, right? Negative 3. So that will be 32. So this is the answer. All right. $32. Okay, then let's do the next one. Now, this fg means multiply, right? So we will find out f of x times f of g. F of times g of x. So that will be x squared minus 9 and 2x plus 6, right? We're going to multiply these two. Actually, you don't have to distribute it, because we're going to replace x with negative 1, right? Negative 1. But let's simplify this, but you don't have to, but let's do it. So distribute it, then 2x cubed, like this, and then like this. So that is negative 6x squared. Multiply these two, then negative 18x. Multiply these two, then negative 54. All right, then we will replace x with what? Negative 1. So 2 times negative 1 cubed minus 6 times negative 1 squared. Okay, when you replace x with a negative number, then put parentheses. It's much safe. It's a safe way. Negative 1 minus 54. All right, then this is equal to, negative 1 is multiplied 3 times, so the sign is negative. So negative 2 minus 6, and then plus 18 minus 54. Then that is negative 30, 10. Wait a second. Okay, so when I multiply this, x squared times, this is plus 6, right? Plus 6x squared, plus. So this will be a plus, right? All right. So that will be 30, negative 32. All right, let's go to the next one. Okay, now the division. Okay, division is, okay, f of x, this is equal to, so we gotta do this one, f of g of x, which is f of x divided by g of x, right? Okay, f of x is x squared minus 9 over 2x plus 6. So that is x plus 3, x minus 3. The difference of squares, and then from the denominator, factor out 2, then x plus 3. Then we can cancel out x plus 3, so that it becomes x minus 3 over 2, right? All right, then let's find out when x equals 4. So 4 minus 3 over 2. Okay, before we do this, always make sure that the denominator cannot be equal to 0, right? So from here, so before we cancel out, we know that this one cannot be equal to 0. So always keep in mind that x cannot be equal to negative 3. Okay, just keep in mind that one. Always keep in mind the restriction. Okay, so when x is 4, then this is 1 over 2, right? So this is the answer. Okay, next definition is a difference quotient. Okay, difference quotient is this one. Okay, let's say there is a function f of x. Okay, f of x. This is a function of x. And we can write an expression like this. F of x plus h minus the function f of x. So x is replaced, the first one is x is replaced by x plus h, then divide by h. Okay, that is the difference of function. And then in this case, we know that the denominator cannot be equal to 0, right? Cannot be equal to 0. Okay, so this means, okay, the difference quotient means like this. Here is the x-axis, just an example. And then the y-axis. Let's say there is a graph, something like this, graph. And then here is a point, let's say here's the x, point is x. Okay, and there's another one. There's another one. This is, this much is h. So h distance away from x. So this will be x plus h, right? So the x value, so the x value of the first point is f of x. So I mean the y value is f of x. The y value is what? The y value of the second point is f of x plus h, right? So as you see this, as you see the numerator, look at the numerator. So numerator is the difference between these two, right? The difference. That's the numerator. And the h, this is h, right? Okay, let me rewrite it. So this will be h, right? H. So if you draw a horizontal and vertical line, this is a right triangle, right? Have you seen, isn't it? If we connect these two lines, 2 points, let me just draw 2 points. All right. It's in a right triangle. And then this is rise. This is run, right? Rise over run. So that is a slope, right? Slope. So actually this is the slope, right? Slope. Rise over run. Rise over run. That's the slope, right? Slope. So slope between 2 points. One is x and the other one is h distance away, apart from x. All right. Then in this case, okay, why don't we reduce this distance? Reduce h close to 0. Not 0, but very close to 0, like a 0.001, 0.1, 0.01, 0.002, 0.1, and so on. So make it very small. So make h very, very small, so it's very close to x. Then this point, as x becomes 0, then this point moves towards x, right? Moves towards x. So this point moves towards x. So it's very close to x. Then once we connect these 2 points, then that is almost a tangent line, right? Almost tangent line. So this will be almost a tangent, okay? Tangent. We call it a tangent line. A tangent line at this point, right? It's a tangent line at when x equals x and the y is f of x, right? At this point. So the difference quotient is a slope, right? It's a slope. So this is the slope. So actually this is the slope. We can say that the slope of the tangent line at x f of x. Can you see it? So we can find the slope rise over run, and as h gets smaller, which means if at x gets to 0, x, then you will make a tangent line very close to the tangent line, so that the tangent line has a slope, right? Slope. So the difference quotient is the slope of the tangent line at the curve. All right. Okay, find the difference quotient of this function. All right, then the formula is what? F of x plus h. H gets very smaller, right? Gets very small and small. And then minus f of x over h. Then x squared. So plug in x plus h. for x, it's x plus h squared plus 7 minus f of x. F of x is x squared plus 7 divided by 7. And then, we got to simplify the numerator. So the square is x squared plus 2ab, so 2 times x times h plus h squared, and then plus 7. Then distribute the negative sign, so negative x squared minus 7 over h. Okay, we will keep simplifying the numerator. So x squared cancel out. And then we have, and the 7 and negative 7 cancel out. So we have only 2xh plus h squared over h. Then we can factor out h. So 2x plus h over h. Then we can cancel out h. So we have only 2x plus h. Right? All right. So we found, we found the difference quotient expression like this. Okay, this means what? If x value is given, then this will give you what? The slope. Something like this. If the graph looks like this, if x for this x value, then this will give you what? The slope at this point. So if h is getting very close to 0, h will be very close to 0, right? So that it will give you this slope at this point. When x, for this value x, that is y, right? At this point, slope of the tangent line. So this is what? It's the slope of the tangent line at x f of x. All right? If h is very close to 0. Okay, next question is, there's a ramp and there's a ball, and a ball is rolling down the ramp. And the distance is given by this. The distance that a ball rolling down the ramp is 4t squared. And t is in seconds. So t is the time in second after the ball is released. So s of t is measured and also in feet. So it looks like this. So if you graph it, if you graph it, and it's starting from 0, right? Okay, this is s, this is t. T is in second. And then s is the distance the ball traveled. So this is in feet. All right, so in this case, we want to find the average velocity of the ball for each time interval. So look at this. We want to find what? Find the average velocity. Speed. What is the speed? It's not speed. Speed is miles per hour, isn't it? Miles per hour, like 35 miles per hour. So that is the speed. And average velocity is, in average, every second, what is the speed, right? Speed. What's the distance the ball traveled? That's the average velocity or average speed, right? So the time interval is this. 3 seconds, at 3 seconds after the ball started to roll, and then 5 seconds after the ball started. So we want to find the average velocity between these two time periods. Okay, so t is what? So t, the first t value is 3 seconds, and the second t value is 5, right? So between these two. So if we graph it, something like this, the graph will be, this is not drawn in scale, but it looks like this, right? It looks like this. Looks like this. So if this is 3 seconds, this is 5 seconds, right? Just an example. So when x equals 3 seconds, then we know the distance that the ball traveled. So that will be s of 3, right? S of 3. And s of 3 is we're gonna substitute 3 for t. And then here is 5, right? Then this will be S of 5, right? S of 5. Okay. So actually the speed is what? Speed is the distance over, that's the slope, right? That's the slope. Draw this line, right? Draw the line. And the horizontal distance is the run. This is the run, right? And this one is rise. So that is the slope, the velocity. In this case, the velocity is rise over run. Rise over run. So that is what? S of 5 minus this distance, right? This distance. That is rise. Minus S of 3 over run. What is the run? 5 minus 2. So this velocity, this is actually the average. This will give us the average velocity, right? So average velocity is, okay, let me write it here. Average velocity. Average velocity is what? Rise over run. Rise over run. So let me rewrite it. So S of 5 minus S of 3 and time 2 minus time 1. So S of 5 is, just plug in 5 for t. So 4 times 5 squared minus 4 times 3 squared over 5 minus 3. Okay, let's keep going. Then 25 times 4 is 100 minus 9 times 4, 36 over 2. Then 64 over 2 is 32. All right, we got 32. So 32 means the numerator is what? Actually, 32 means what? 32 means 32 over 1, right? So 32 is the distance, right? Distance. Distance the ball traveled in feet, right? In feet. And denominator is the time, right? Time in second. So this one implies that the average velocity is 30 feet. The ball rolled 32 feet per second, right? All right, can you see it? So in that case, the average velocity is rise over run. Rise is the distance, run is the time in second. So we can find the average velocity between the time interval 3 seconds and 5 seconds. So what if we reduce the time, the second, the end time to getting close to 3. So that is letter B. Let's try letter B. Okay, the letter B is the time interval is 3 and 4. So let's decrease the end time, close to the starting time. So starting from 3 seconds all the way up to 4 seconds. So let's find out the average velocity. So in this case, this is T1, right? T2. So let's find the average velocity. So let's use the velocity. So let's use S of what? S of 4 minus S of 3 over what? 4 minus 3, right? Okay, so that equals S of 4 is 4 times 4 squared minus 4 times 3 squared over 1. Then that equals 64 minus 36 over 1. We don't need over 1, right? So 28. So the average velocity in this time interval, 3 seconds to 4 seconds, then the average speed will be 28 feet per second. Okay, let's try more. So how about the average speed between 3 seconds and 3.01 second? Look at this. Now the end time is very close to the starting time, right? So T1, T2, let's try what happens. So S of 3.01 minus S of 3 over 3.01 minus 3. Then 4 times 3.01 squared minus 4 times 3 squared over, that is 0.01. Then in this case, use a calculator. So that will be 36.2404 minus 36 over 0.01. Then this one is approximately equal to 24.04. All right. So between, the average speed between 3 seconds and 3.01 seconds. So actually this is almost at 3 seconds, right? Then the speed is 24 feet per second. That's the speed. So if the time interval is very, very short, very, very short, then it's gonna be it's the speed at the instantaneous speed, right? Instantaneous speed, right? Because if the T2 is 3.00000001, then it's almost the speed at 3 seconds, right? At 3 seconds. Can you see it? Right. Let's try our next example. Okay, next definition is the composition of two functions. So let's say there are two functions, f of x and g of x. Then we have a notation like this. F circle, this is times circle g, parenthesis, and then of x. Okay, this means this is not a product. Okay, this is not equal to this one. This is definitely different from this. Okay, this is a product, but this is called the composition of functions. Composition. So f circle g. Okay, f circle g, not dot. Okay, so this one represents, there's a function f of x, right? F of x, but the input of the function f is g of x. Can you see it? So, once you get g of x, then g of x will be replaced, will be substitute for x for the input of function f. Okay. All right. So can you see it? This is really, really important concept. So something like this, f circle g of x. Okay, again, this means okay, here is f of x, right? F of x and g of x. Then this g of x, goes to the input of f of x. Okay, so you have f of x, right? F of x, and then this x, the input of f will be g of x. Okay, don't forget this one. Okay, so let's find the composition function of f and g. So f circle g of x means what? The input of the function f is the function g. All right, so we're gonna write it like this. So that equals f of what? What's the g of x? G of x is 2x plus 1, right? 2x plus 1. Then we're gonna replace x in the function f with this input value. So x, so this is the f of x, right? F of x. So this x will be replaced by this input. So x squared minus 3 times x. X is what? 2x plus 1. Does it make sense? Okay. Right, then this is equal to, then we need to distribute it. So a squared plus 2ab plus 1 squared, then minus 6x minus 3. Then simplify it, so 4x squared minus 2x minus 2. All right, that's F circle G. Okay, F circle G. How about G circle F? Okay, that means the function G will have an input that is f of x. So f of x will be the input of G. So the function G is 2 times what? 2 times x plus 1. So this x will be replaced by what? F of x, right? F of x. So 2 times, what is f of x? X squared minus 3x plus 1. So 2x squared minus 6x plus 1. So that is the result of G circle F. Okay, now let's evaluate F circle G of 3. And then f of x and g of x are given. Okay, we can solve this in 2 different methods. Okay, let's use the first method. Okay, so this means, okay, what do you mean by this? This means f of what? G of x, right? But g of x is 3. In this case, x is 3. X is 3. So let's find g of 3 first. So from here, what is g of 3? G of x is x squared plus 4. So we will replace x with the input value 3. So 3 squared plus 4. That is 9 plus 4, then 13, right? So g of 3 is 13. So we can replace the input g of 3 with 13, right? 13. Then from here, what is the f of x? F of x, 2x minus 7, right? So we're going to plug in f of 13, right? F of 13. So f of 13 is, okay, let me write it here. Okay, maybe it's confused. So f of 13 is what? 2 times 13 minus 7. Then 26 minus 7 is 19. All right, so this is method 1. There's another method. Okay, let's find out f circle g of x first. All right, and this one is equal to what? F of g of x, right? So that the function f of x is 2x minus 7. So why don't, so actually this is what? Okay, here. F of x is 2x minus 7, right? So we're going to replace this x with what? G of x, right? Replace x with g of x. X with g of x minus 7. So that equals 2 times what's g of x? X squared plus 4 minus 7. Keep going. 2x squared plus 8 minus 7. So 2x squared plus 1. So this is f circle g of x. So, f circle g of x is equal to 2x squared plus 1. And then from here, we want to find what? 3, right? 3. So what you do is plug in 3. So 2 times 3 squared plus 1. Then 2 times 9 plus 1 is 18 plus 1 is 19, right? 19. So we have the same answer. Okay. So you can change the expression in terms of x and then plug in the x value, the input value. Or you can just directly plug in the input value so that you find g of some number, g of 3, and then use that value as an input of function f. Okay, now we have another example, but that's not that important. So let's stop here. So this is the end of this section.